Hello guys, welcome to the Leetcode series. So in this video we will be solving the Leetcode question number 21, merge two sorted lists. First let's go through the problem statement. So you are given the heads of two sorted linked lists, list 1 and list 2, and they merge the two lists into this one sorted list. And the list should be made by splicing together the nodes of the first two lists. So return the head of the merged linked list. So here you can see the diagram. They have given the two linked lists. So both are in the non-decreasing order, and we have to merge into the single linked list. And coming to the constraints, the number of nodes in both lists is in the range of 0 to 50, and both are sorted in non-decreasing order. Let's see how to solve this problem. Yeah. So we are given two linked lists. First one is red one, 1, 2, 4, and the second one is green one, 1, 3, 4. So the final linked list that we want is 1 1 2 3 4 4. In this video I will be explaining two approaches. One is pretty straightforward and the other one is the optimized solution that we want. So and I will discuss the time complexities of both solutions. So the first solution, which is pretty straightforward, that everyone can think of. So what we can do is we can extract these elements from the both linked lists and put it in one list. So here I extracted the elements. So 1 2 4 1 3 4. Then do the sort operation on those lists, and then convert that list into the linked list again. Then return the head of that new linked list. That's one solution. So coming to the time complexity of this approach is the sort algorithm may take it take the n log n time, and again converting that to the linked list we have to traverse through all elements in the list. That will take O of n time. So the total time complexity will be n log n plus n. So but we want the optimized solution. We don't want this kind of solution that the interviewer in the interview he don't expect these kind of approaches. So you is supposed to do in the optimized way. So the time complexities matters. So now let's see the optimized solution. So here you can see the two linked lists separately, the red one and the green one, and I pointed out two pointers x and y, which is starting the head of the both linked lists, and I created one dummy node and I put 0 in that dummy node. So now right now we have three linked lists. One is red one and the other one is green, and the other last one is the blue one that we are creating new sorted major sorted linked list. So let's compare the x and y. So in the x we have 1 and in the y also we have 1, so both are equal. So we can take any of the node and connect it to the dummy node. So I took the red one. Now you need to shift that x pointer to the next 2. Then just now compare again x and y. In this case 2 1 1. So in this case 1 is the smaller one. So I will take the green node, then connect it to the newly created linked list. So now again shift that y pointer to next. So now compare again x and y. So 2 is the smaller. So now I will add the two node to the newly created linked list. So then again shift the x pointer. Now again compare x and y, 4 and 3. Here the 3 is smaller. Just take it out and add it to the newly created linked list. Then again shift the y pointer, then compare it again. So here in this case both are equal. You can take any of them. So I took the first green and then finally the red one. So now we created the new linked list. So in this scenario the first linked list is longer than the second linked list. So in that case the common elements are over. Now the rest of the elements are from the red linked list, 7 8 9. So what you can do is you can directly take 7 pointer node and connect it to the fourth one, the newly created linked list, that add it to the tail. So you can take the 7 8 9 and add it in the last. So that's how you do. So coming to the time complexity, this approach will take off n time And coming to the space, here we're having two linked lists. So one linked list contain n elements and the other linked list contain m elements. So at the end we are creating a new separate linked list, so it will take of n plus m space. So there are other approaches also are available, so that you can do it in O of one space. You can do the in place solution also. So next we will write the code in Python and Java for this problem. So now let's write code in Python. So first we have a two linked list A and B. First you need to create one dummy node. Dummy equal to list node. Just added 0 into the dummy node. So I'm making the copy of that address. Temp equal to dummy. Now you need to traverse through both linked list A and B. So let's say while A and B. So here we are using the while loop because sometimes A contains more number of elements than B and the B contains more elements than A. In that case, when any of that ends, any of the linked list like the pointer, if it ends to the end of that any of the linked list, so this we will get out of this while condition. So next you need to compare the values from A and B. So A dot val less than or equal to B dot val. If it is true, then we add that node to the dummy linked list. Dummy dot next dummy dot next equal to A, and we shift the pointer from A to A dot next. So A equal to A dot next. Right now like we are shifting the X pointer. So now next else on dummy dot next equal to B and B equal to B dot next. So we almost completing the code. So then next and here don't forget you have to shift this one also. Dummy dot next, you need to travel, you need to move to next in the dummy linked list also. Equal to sorry dummy equal to dummy dot next. So now you are traversing in both A and B. So in this case, if A gets the X pointer ends in the linked list A, just you will come out from the while loop. The same case in the B. So in that case, the some elements will be left in A linked list or in the B linked list. So in that case, you need to make sure that edge case dummy dot next equal to A or B. So if A contains any extra elements, just directly add it to the dummy dot next, or if B contains B, just add it to B. So that's you need to do. Then return, I need to return the head of this dummy linked list node, but the starting address I stored in the temp. So I'm returning temp dot next. So ignore the first 0 value. You shouldn't pass that 0. Say run. So submit. So it's accepted. So now let's write. So first you need to create one dummy node. So list node dummy equal to new list node. Then make a copy of it. List node temp equal to dummy. Make sure you put semicolons. So next open one while loop. While, so here I'm changing these names here. B. So while A not equal to null and B not equal to null. So if if a dot val less than or equal to b dot val, just dummy dot next equal to a. So a equal to a dot next. Similarly, else dummy dot next equal to b, b equal to b dot next. So in the end, you need to update the dummy also. You need to move front in the dummy linked list also. Dummy equal to dummy dot next. So now you need to check the remaining elements. So if a not equal to null, dummy dot next equal to a, and check for this one also. B not equal to null, dummy dot next equal to b. So now return temp dot next. So let's run it. Hit the submit. Yeah, that's it for this video, guys. I will see you in the next video. Thank you.